Hi everyone, and welcome to our video on solving a trig equation that has a special angle. So this time around we do have a tangent equation, and we see the special angle is 5 theta over 2. So again, non-special angle is just like theta or just x. Okay, so this one's special, but the way that we want to do it is we want to isolate the trig function. So we want this all by itself, which means on this problem we should multiply each side by 3 over square root of 3. Okay, so we're just multiplying by a reciprocal, and then that would give us the trig function by itself, tangent of 5 theta over 2, equal to negative 3 over square root of 3. Now this, we can rationalize the denominator. So if we multiply both the top and bottom by the square root of 3, we would have tangent of 5 theta over 2 is equal to negative, well, let me show that scratch work to the side so we can save one step of rewriting. So we would have that, and then we would see, oh, those 3's would cancel. So it should be just negative radical 3. And then tangent, now I have a trick with tangent. So if tangent has the square root of 3 as an answer, I know that that means in radians, the denominator should be 3. And so where I have denominators of 3, where tangent is negative would be in quadrant 2 and quadrant 4. So 2 pi thirds and 5 pi thirds is where those angles would match for where tangent is negative radical 3. So that means this angle, this 5 theta over 2, should equal those two angles. So we'll have 5 theta over 2 is equal to 2 pi thirds, and now is where we would just instantly put in the 2 pi k, and then comma, 5 pi thirds plus 2 pi k. Okay, and then like the last problem, we do want a common denominator, so let's just put a 1 there as needed, and then we'd say, well, both of these would get multiplied by 3. So we would have 5 theta over 2 is equal to 2 pi plus 6 pi k over 3, comma, 5 pi plus 6 pi k over 3. And then our final step to get all the answers, so we have two parts to this, all the answers is to multiply by the reciprocal here. And then that does multiply each of these. So there's the 2 timesing the numerator, and then the 2 and the 5 timesing the denominator. Okay, so we multiply all terms, which gives us just theta. And then in the numerator, that 2 would distribute. So we have 4 pi plus 12 pi k over 5 times 3 is 15, and then comma. Again, the 2 distributes 10 pi plus 12 pi k over 15. Okay, so this is part A. This is all solutions. So the tangent one took a couple more steps. That's okay. All right, now we need to find the solutions in the interval that they want. Okay, so let me erase just a little bit. Okay, so let me get rid of that. That way I got, I think, enough space. All right, so now we're doing part B, where we are saying let k equal 0, 1, 2, so forth, however many we might need to do. But usually I'm just looking for accounting of a pattern, and I'm just highlighting it. This is where we should be doing addition by 12 pi to our numerator to get different answers. Okay, so now we've got theta equals, okay, so again, if I let k equal 0 in those two answers, so that k and that k, then if it's 0, I mean that second term is gone, and we're left with 4 pi over 15, comma, and then, whoop, freaked out a little bit. Sorry, there we are. Oop, I don't know where that k went. There we go. Okay, so the 4 pi over 15, and then the second one, if we let k equal 0 in the second one, then we'd be left with 10 pi over 15. Now, we would say that that will reduce, but let's reduce it later. Okay, comma. And then now when we let k equal 1, and this is where, let me highlight in purple again, that's where that addition of 12 pi will kick in. So I'll add 12 pi to the numerator, which gives us 16 pi over 15, and then comma. If I add 12 pi to the numerator, I would have 22 pi over 15. Okay, so that was when we let k equal 1. And then now we're still just going to continue doing our pattern. If I added 12 pi, okay, so let's show the arch. So there's an addition of 12 pi to the numerator. And then here was an addition of 12 pi to the numerator. I want to keep it going. Okay, so this answer I'm going to add 12 pi to again. So that's giving us 28 pi over 15. And then if I add 12 pi to this one, we would have 34 pi over 15. Now notice our numerator 34 compared to our denominator 15. When those divide, that's bigger than 2. So this is bigger than 2 pi. So that means we don't want it. So goodbye. So that means we do have all of our answers. Now this 10 pi over 15 does reduce. I'm going to box all of them right now. But we would reduce that. I'm just looking at my space and looking at the time and saying, well, that one should. Those are each divisible by 5, so that one would convert to 2 pi thirds. Now to save some time, I'm not going to write all the answers over again. I'm being a little sloppy, but let's save a minute and just say, hey, thanks for watching. If you do have any questions, please let me know. We'll do one more in another video, but I'll see you then next time.